Here's another example of problem solving with Newton's second law. Here we go. A 50-kilogram girl stands in an elevator that accelerates upward at 2 meters per second squared. Consider the forces acting on the girl. Draw a free body diagram of the girl and determine the value of all forces. So let's draw the girl. Here she is. She's standing in an elevator, but I'm not going to draw the elevator because it says consider the forces acting on the girl. I could draw a free body diagram of the elevator, but that would be a different interaction. I want to focus on just what's pushing and pulling on the girl. So let's identify some forces here. So first of all, she's got gravity pulling her down, and that's equal to her mass of 50 kilograms times the acceleration due to gravity on the Earth. So her weight is 100 newtons. I'm sorry, that's not right. 490 newtons, my bad. And she is going to have, she's got this elevator floor underneath her supporting her, right? So I'm not going to include that in the diagram, but I am going to include the force from the floor, normal force. And I don't know what that is, so I'm just going to call it a question mark. But I do know her acceleration, so I can find the net force on her, okay? Acceleration is net force divided by mass. And by the way, I can rearrange that this way. Net force is mass times acceleration, right? So that's going to be her mass of 50 kilograms times her acceleration of 2 meters per second squared. That's an upward acceleration. So the net force on her is 100 newtons. I'm going to draw that with one of my block arrows, the net force of 100 newtons upwards, right? Because it said she accelerates upwards. And then I'm just going to now go back and try to make sense of the picture, right? The sum of the forces needs to be 100 newtons up, and I've only got two forces in this interaction. So according to the free body diagram, I can figure this out, right? The net force is going to be equal to normal force up minus gravity down, right? The net force is 100 newtons. The normal force is the unknown. Gravity is 490 newtons. So the normal force, meaning the force of the elevator floor on her, must be 590 newtons. So I can go ahead and write that in here. And now the sum of the forces is indeed 100 in the upward direction.